Good afternoon. I'd like to just introduce myself. My name's Ivan Tate. I'm the powertrain manager for North America. I've been with the company 7 years, and previously to this job, I was working on an integration role related to engines and vehicles. So what I'd like to do is run through a number of the interesting or relevant profiles that we've closed, explain some of the issues, give a bit of background, and give everyone the opportunity to type in or ask any of the questions that you may have.
Yeah, Ivan, this is Rick. As we've done in the previous presentations, Q&A box over on the right side. Feel free to type your questions in, and we'll do our best to answer them as we're going along. And again, this presentation will be recorded, and we will get it moved over to the Tech Knowledge section on the dealer portal. In case you had somebody that wasn't able to attend this today at your dealership, they can go back at any time throughout the year and view it again. So with that, Ivan, take it away.
Okay. Right. So really running through majority of the cursor issues here. I'm going to start out with the CP5 pump. This was a fairly high failure rate starting probably back in 2016, and we made an investigation. We saw a lot of low pressures. We saw a lot of pump damage. You can see there, probably up to nearly 70%. In terms of claims, the resolution you may have seen was rolled out in late 2017 or early 2018. Now, knowing that the new vehicles had that pump, and we've seen very few fail after the breakpoint for the new part, we also have seen no let up in the failure rates, despite the park reducing. So we're going to continue to recall these pumps, and we should be recalling these back, and we're investigating those with Bosch here in North Carolina. The issues that we've seen in the past are abrasion and wear or cavitation on the valves. This creates both leaks and pressure spikes within the system. So primarily, the issue has been resolved. All new engines throughout 2018 were fitted with the new component, but we're continuing to recall to ensure that we have full coverage on all the failure modes seen on this part. The next one is the next two will be related to the scraper tractor, or the four-wheel drive scraper tractor, focusing particularly on the two-stage engine. The Cursor 13 two-stage high-pressure turbocharger, we saw a lot of claims here related to wear on the thrust bearing. So you saw a lot of axial play on the turbocharger shaft, as well as oil and contamination throughout the intake circuit. Our investigation, again, we spent time out in the field with the machines, with instrumented parts, as well as taking a lot of returns. Our investigation led us to the fact that at some conditions of load in transient, particularly on the scraper application, although you may see this elsewhere at times, caused the oil film to break down on the thrust bearing, and we had accelerated wear on that bearing. There's a new turbocharger fitted. You can see roughly April from production date, April 2018 that is, with an increased capacity thrust bearing. This has to be installed along with a new engine data set at the same time. The reason for this is that there is extra drag on the higher capacity thrust bearing. There's more surface. So we had to retune the combustion and the fuel injection to match the change in the airflow. to remain compliant over the EPA cycle. So just to reinforce that, the dataset and the turbo have to be installed together. The second component on these two-stage machines is the charge cooler. This, you can see here in the image on the screen, we have localized boiling, and that leads to erosion of the aluminium components within the cooler. This again was really a victim of a very transient cycle. That's the engine speed changing dramatically, returning to idle after full load, and then obviously load being applied quickly again. The coolant flow within this secondary circuit is controlled by an electrical pump. So we have the ability to modify the flow based on, or independent to engine speed, but based on load. What we did here to increase the amount of coolant, to reduce the amount of time that coolant has in the cooler to absorb heat and to boil, is increase the flow. So to optimize the flow rates, not only did we stop the pump returning to a lower flow rate at idle, but we actually changed the distribution of the flow between the two coolers. So there's now an orifice on the input to the high pressure charge cooler. And within the data set or the calibration that I mentioned for the turbocharger, we also have an increased speed on the electrical water pump for this circuit. Again, you can see on the slide here that there's the part number for the orifice, and there's also obviously a pip for the scraper tractors for the rework. The data set can be installed without the orifice, but not the orifice without the data set. So as a check here, if you update the turbocharger, but you don't have issues with the intercooler, you can update the data set without concern. Okay, next one up. This is the Combine flywheel. I think quite a few people may have seen this as the season moved on through 2018. There's an oil leak very close to where the bracket for the DOC fastens to the flywheel housing. Essentially, we had two flat surfaces here. We've had to increase the area where the sealant has to seat or seal between the two faces. Previously, the faces were bolting up and obviously pushing all the sealant out, and there was nowhere for the sealant to actually adhere to. So a modification on the bolt torque to make it more consistent, and then we added a chamfer to allow, as you can see in the image, some surface area for this to seal to. In the previous discussion, I took the opportunity here to flag up the timing routine of the Cursor engine. We've had a few engines returned a few hours after having this rework performed on the flywheel housing. And they obviously were a victim of a timing, so we say a timing issue, valve piston contact on all pistons. I'd like to just reinforce that the Cursor timing routine does require some concentration. It does need to be gone through very thoroughly to ensure that we don't get any further claims on it, complete engines after flywheel housing replacement. Sticking with the Cursor 16, there was an issue. I put this slide in really to emphasize that every engine that gets every engine that fails comes through our workshop here in North America. We analyze, we inspect, and we send away to any suppliers or the relevant manufacturing plants a sample of the failed parts. So this one I left in because we'd had one failure. We actually, in the last few months, had had 2 more failures due to the same issue here. The rod bolts were not tightened correctly. We've had a task force in the Cursor engine manufacturing plant to review a lot of these processes. And what happened here was that the engine was actually stood on its side to tighten these Conrod bolts, and it meant that sometimes the machine didn't get a full engagement on the bolt, and we could see the tool slip or damage the bolt head without reaching the required torque to fasten the Conrod. So it was quite a large change on the production line to change the station, to rotate the engine another 90 degrees, and here the actual weight of the tool sits on the bolt heads, on the spindles, to ensure a proper engagement. Okay, moving back down the engine line in terms of size, we have the Cursor 13 head gasket issue. There's been 1 or 2 machines that we've been out to see in the field, as well as a number of engines that we had returned. You can see there's a list of engine serial numbers there. Some that we were able to recover prior to teardown at the servicing dealer. Some with liner protrusions that were too low, some with liner protrusions that were too high. And this was really the same root cause. The machine itself, the same symptom, although the root cause was slightly different. One was the wrong shim was selected, and the other was that the shim was actually damaged as it was put into the cylinder block. And the production facility here has obviously a machine to check liner protrusion, but what we had to implement was an automatic rejection. So there was no manual or automatic override when a block was found out of specification. So this would then force the rework of the block, removal of the liner, a reselection of the shim. This was introduced just before the summer shutdown. There's a serial number, I think, there's a serial number listed here. We'll obviously continue to follow any Cursor teardowns on these engines to ensure that the implementation of this has worked. Okay, Cursor 13 cylinder liner cracks. We've had a few of these come in. This fix or action actually applies across all Cursor engines. What we had seen in the plant after investigating the handling of these liners was that we had to support them better on their cart. You can just see the white cart in the image there. This is how the liners are transported around the facility, or shall we say between sub-assembly and assembly into the engine block. And also within this area, the O-rings are also installed on these liners. The liners themselves during this phase could crash into each other. You can see that was relatively simple to tip, and also they can fall off this cart if not, or obviously move too quickly. So there's an increase in height of the boss, shall we say, that these liners sit on, as well as you can see a shield and a rack around the top edge of the cart was implemented. This removes any chance that a liner that could hit another liner possibly damaging both of them, or that any liner that has fallen off the cart or say anywhere else could be reused. So along with obviously some operator education to ensure that didn't happen, we have physical stops to make sure that it cannot happen. Okay, Cursor 13 crankshaft failures. This manifests itself as both, either a seized bearing or a broken crankshaft. This happens only, or has happened only, on the fourth bearing. We spent a lot of time investigating this. As you can imagine, that once this happens, there's not a lot of evidence left most of the time. Quite often the engine block itself was broken or cracked around the bearing. They say the crankshafts were often completely destroyed and there was nothing left of the bearings. So we took the approach that we needed to be robust on the bearing installation. We also had to protect the crankshaft dimensions, and then we continued to study the machining process by looking for, shall we say, similar engines, similar age part components. So for all of these possible root causes, we actually made improvements. So first of all, we ensured that the bearings were, the carrier for the bearings was both clear, and it was impossible to mix up the bearings or install the wrong bearings once the class had been determined by measuring the crankshaft. That was a production line improvement. We also found some question with regards to the crankshaft inflection. This is the process by which the heat treatment bends or changes the shape of the crankshaft, and obviously this is built into both the design and process. We modified the cooling of the crankshafts, and also with regards to post-measurement of this inflection, we gave the opportunity for the crankshaft to go back through heat treatment to correct any dimensional issues rather than being passed forwards into the production line. So both of those, there was opportunity for improvement. We took that opportunity, but where we actually found the real root cause for the failures that we were seeing was taking a crankshaft from spare parts. Fortunately, this crankshaft was only one serial number different to the crankshaft in one of the failed engines. And we found a burr in the oil gallery on the crankshaft on that part. This was part of the machining process. Obviously, the tool wear was leaving just it was a very small burr at the end of the oil gallery. On the two-stage engine, the bearing shells are flat; they don't have the oil groove. So this gave that burr nowhere to go once it had snapped off with the passage of oil and the movement of the crankshaft. So not only did we implement a extra cleaning process on the line immediately, we also reduced the expected tool life on that particular machining component. That has been in production. We cleared out the spare parts, and we've not had any further failures after the breakpoint. As you can imagine, these failures manifested themselves very early on in the vehicle life.
Hey, Ivan, we've got one question up there. May as well catch that one while we're right here. It's has a new test procedure come out for testing 5.2 fuel pumps and injectors? Or basically, is it just, I mean, kind of what we do now, we have to swap them out to see if that fixes the problem, but there's probably no other test procedure yet, is there?
So we are working on it, and I don't know when the last time everybody was told that we are working on it. The process is actually being developed by FPT and obviously the technical help desk team, and it's actually with Bosch for approval or modification at the moment.
Okay.
I don't have a date on that. That's something I'll put down as a note to try and confirm, or even better, shall we say, try and accelerate. Okay, Cursor 9 fuel pipes. We've seen a number of failures on the Cursor 9 fuel pipes, different failure modes. This one was to do with cracks at a very low working hours. We had two issues here. The first one, which is the real root cause, that we were actually over-torquing the bolt, or should I say the nut that clamped the pipe onto the fitting. This gave the problem of increasing a torsional torque to the pipe due to the friction between the nut and the pipe head. So we were seeing failures very close to on the pipe, very close to the back edge of the nut. We had to bring that back within process, within the torque spec. It was, there you go, 35 Newton meters. That was done in the middle of the year, start of July. And then there was as part of the investigation, we found a misalignment in our bill of materials where we were using a slightly different pad or dowel to support the pipe in the middle of its length to the head. That has also been corrected. We brought that in very recently in December. And that corrects any factory installed issue with these pipes. Another, shall I say, slightly offline comment here to make is to remind everybody that the requirement is to replace these pipes when they're removed. They're a single fitment item. We do see engines come back with fuel in oil, and there's a very clear leak path past on the sealing edge of these pipes. You can put them under a microscope. You can see it very clearly where the fuel is leaked, and it erodes very quickly the material. So just a comment there that reusing the pipes will mean that you don't make that seal as well as it should do. The Cursor 13 oil filter. We have seen some engines seized due to oil contamination or let's say blocked oil gallery components. So in the turbocharger and the oil jet, the oil filter bypass, we found a weakness in the oil filter bypass on some of these engines, which has allowed the strap components and unfiltered oil to circulate the engine. The component itself has been validated over 1 million cycles. We are now improving this part to make 2 million cycles with no appreciable wear. So you can see the two designs. One is a pressed leg that's hooked over the spring, whereas the proposed item, or the one that we're now tooling, is a full pressing. It It's not a simple two-leg design that can wear with the abrasion of the spring or fatigue, and it will, if there was any issue with the spring, it would keep all the components within that shell. So we are working on validating it. The 2 million cycles are actually running at the moment. But we have also tooled up these components in advance, and we expect to see these coming into production for April 2019. So unless there's any big issues that we find after the teardown and check of the components that are being validated, we've taken the opportunity to tool this and get the parts to market more quickly. We are making ongoing tests with various test machines around the country. I had a guy in Fargo a couple of weeks ago. As you can probably appreciate, finding opportunity to make a cold start in Fargo wasn't difficult at all. There's, I think, about 5 or 10 degrees below zero up there. We have fully instrumented filter housings. We've had an array of aged filters from 0 up to 800 hours usage. So outside of the service window, we've been making those tests in cold conditions. We're going to continue instrumenting machines to gain more knowledge as to how shall we say, the machine installation or machine use may affect the oil circuit on these machines in terms of temperatures and transient behavior. Okay, the next 2 pages are more related to Cursor 9 turbochargers, something else that may have affected a number of people listening. They have an interest in this. There are 2 pages because we have 2 very clear activities. This first one is the return spring unit, or the RSU, for the VGT mechanism. And this manifests itself as error 3450. On a number of components, you probably know that we've had these on recall for a while now. We obviously had to investigate all of the parts that were coming back in. One of these was to manually, separately move the actuator, and we found a number of them were becoming bound up. The spring sits on a shaft, and the spring itself was below tolerance. So as the actuator opened, the spring inner diameter reduced, and it actually bound to the shaft that was turning. This increases the torque, so occasionally the actuator cannot overcome that torque, or it becomes stuck in a certain position. We flagged up a reappear test. We actually did that here in Burr Ridge. We took what we thought was a failed component, put it onto a good tractor with Garrett here on site, and made that reappear. The error code came back and followed the RSU between turbochargers. This component is now, as soon as we found that root cause, is now subject to 100% check on dimensions within Garrett. All the turbochargers being fitted to engines from next week will be cleaned. We've removed the old turbochargers, or as many as we could, from the supply chain, and we've worked with the supplier and flew turbochargers to the production plants. We're trying to make an additional check here. As we know, the feedback from the turbocharger itself would be useful for the guys in the field, to make much like you have a UDST test for the DEF system, make a turbocharger test that could manage the boost, manage the actuator position, and give feedback on the EST. That's ongoing at the moment. We have a few different ways that we can do this. We're looking to implement a feedback based on the current of the actuator for this particular RSU failure, but we also want to integrate any other improvements or parameters to check, such as boost pressure or the position versus engine speed that we can. So this is the main turbocharger slide. If we look straight at the root cause, we analyzed 87 components so far. You see 15% of these were actually no trouble found. Then we had 12%, which is oil carryover. We have a oil deflector that will be installed on components, which is going to be available, I think, from components from approximately April. It's taken a bit longer to implement because it's a new component as opposed to the RSU, which would be a component check and rejection of out-of-spec parts. 1% was a sensor wiring harness failure. There was a new clip with a rubber boot that was on the high temperature green wire that went across the back of the turbocharger. 35% was external damage to the compressor wheel, so either hard parts, oil, carryover, whatever else. So the turbo is classed as a victim. 22% kinematics, that's the RSU on the previous page. And then 13% that we couldn't put directly down to the RSU in terms of the EVGT mechanism not delivering the correct operation. So along with the 22% that were covered on the previous page, the 12% for the oil carryover is coming in April. And then we're looking at approximately 35% as a victim and 15% as no trouble found. So that's 50% overall that we need to confirm or at least try to reduce using the troubleshooting procedures that are out there. If there's any feedback on that troubleshooting procedure for these Cursor 9 engines, please tap away on the keys and I can make notes on that.
Hey, Ivan, just as a side note, we're a little bit over halfway through our time slot.
Okay. I think we're moving on okay. So this one's going to be a quick one. The item that we discussed on the Cursor 16 earlier will roll out or has rolled out onto the Cursor 13 and the Cursor 11. We've seen an increasing number of machines with claims for exactly the same issue here, and obviously the action is exactly the same. Okay, I think this is rounding out the Cursor 13 or the large cursor engine points. We had a number of engines, 11s and 13s, with loose conrods. This could be low oil pressure or eventually a rod through the block. We saw that the threads were damaged. We saw that there's a lot of evidence of loose bolt or under-torqued bolts. Reviewing the process on the line here, we had an issue where we could over-torque the bolt, and we also had issues where we could reuse the bolt a number of times. The conrod and the bolts actually come as matching sets, or at least sets together. So we didn't readily have bolts available, so if the production line needed to retorque a bolt, which had already been stretched, then they ended up retorquing the same bolt. So we reduced the window, the torque window for these bolts, so we could have a more reliable tension within the bolt shank itself. And then we've eliminated the fact the operator can reuse the same bolt on the production line. This currently is classed as a containment. Some of you may know the 13 and the 11 actually uses different bolts. Our final step is to standardize the bolts used on these rods. It requires a slight redesign. This will mean that we can keep bolts in the production facility, and there's no risk of an operator using a 13 bolt in a, shall we say, a rework scenario, using a 13 bolt in an 11 or vice versa. This is a risk, as there's only a couple of millimeters difference between these two bolts. So until we have that finally implemented with the supplier, this will remain a containment. Although this, currently, we have no further failures after the break point of the new torque and operation, which was done back in 2017. Okay, so now we're moving on to F5s. The big one here, we have both camshaft seizures, and well, there's obviously balancers as well also affecting tractors. So some of you may have seen tractors, so anything with a auxiliary pump fastened to the PTO and the engine, see a failure on the camshaft. This usually seizes the camshaft into the block. Externally, you can see the paint burnt off the block, or sometimes a hole actually in the block around the camshaft journal, area of the camshaft journal. We actually dual source these blocks, and we found a different root cause that we made a reappear on each from each of the suppliers, both CMD and Zymai. So the Zymai actually had a block a machining issue and causing a problem with roughness. So as the bushing was inserted, we ended up with inability to make an oil film. And the CMD blocks had an issue with concentricity between the camshaft journals. As I say, we ran both blocks. We found blocks that followed the spec and understood that within 80 hours we could make both failures reappear. So there's been machining improvements in Zymai. We reduced the amount of operations per tool in July, and then put a new machining process and additional polishing process from September. With regards to the concentricity, we improved the checks on the blocks in October. We actually now check the concentricity with the bushing in the block. These are now classed as containments, as we're making further improvements to the process to ensure that this doesn't go back out of process in the future. Both of these blocks are subject to a PIP that was released in December. Okay, similar to the previous one, engine balancer bushing, this affects the same machines from a very similar era, starting early 2017. This was a concentricity issue on the balancer. It walked the bushing out of the balancer, manifested itself as a knock, or engine damage from contamination or from the balancer taking out the crankshaft or the bottom end of the engine. This, again, it's very clear what is happening to the engine, and we released the campaign, or the PIP, in late 2018 to cover this. This one, the F5 fuel injector and injection circuit, this one has been put in that we're to highlight. It's not yet a closure. Again, looking for feedback. We now have these components on recall. We've seen a high failure rate, particularly on specialty tractors, but also the small tractors and the skid steers are also affected to quite a high degree here. We already have filtration improvements, but we're working with the platforms to ensure that there's no design issues, that's cleanliness of components or assembly issues in the way the components are shipped or stored on the production line. So this one currently is for information only that we are actively investigating the F5 fuel injection circuit. Okay, this is a big one, the supply module on the DEF circuit. We're moving into the after treatment slides now. We obviously have seen a high failure rate on these components. It's been on the map, and we've investigated both pump, should we say, lack of pressurization and also pumping loss, along with any other hardware damage. There's two activities here. One is improvement of filtration. We have in-tank filtration, which we're moving to 40 micron. That's happening on everything but combines until there's a new filter introduced at the bottom of the WEMA. That's the sender unit. And then we also have a new supply module being released with what we call a cold flex membrane. This is a membrane that will seal better in cold conditions. It retains the flexibility, so we gain pressurization, performance, and we don't have any, based on new components, new seat inside the pump, we don't have any additional wear at higher depth temperatures up to the 60, 70 degrees that we see in service during summer activity. This is rolling out. The part number should be in service parts by the end of March, and I know that the production plants are also receiving parts throughout March, and they'll be obviously installing those components on machines from that point onwards. Again, the other supply module, we, along with the investigation on the 2.2 unit, that is anything that's on the NEF cursor, we're also working with the 6.5. This is fitted to all of the SCR systems on the F5 engine. We have a lot of components, again, returned, no trouble found, which point towards cleanliness or sealing issues that may have disappeared by the time the part has been moved or shipped, or continued to work for a short period of time. So we're working on both ensuring the service information is clear, and I think that was there was some information released last year. We're also releasing new software for all F5 vehicles. That's rolling out as over since December, and we'll do over the next couple of months to improve pressurization, more attempts at pressurizing, and also improving the shutdown procedure so we collect less DEF deposits on the dosing valve and blockage. We have an additional proposal to attack the two error codes you see here, 19336, 19337. That is being sanitized, shall we say, or prepared and by TechPubs at the moment for release. It was shall we say, an engineering download that should be ready for release within, well, should we say before the main season starts, but within the next 1 or 2 months. Okay, I probably don't need to talk about the dosing module here. This was, I mentioned it previously, that we're releasing the data sets. You can see the dates that on that slide that they're released into machines for testing and validation. We're stepping through that at the moment. Right, to try and get to the other big ones. First of all, I know that there's been quite a few NOx sensor issues out there. If you work with the four-wheel drive tractor, if you work with the sprayers, and also wheel loaders, if there's any CE guys listening. This is generally a problem with condensation in the exhaust line. We also have improved the amount of DEF injected at low speeds, low temperatures, to ensure that the DEF doesn't cause us an issue here. But the main thing we are doing is eliminating the chance of condensation hitting a functional sensor. And when I say a functional sensor, the sensor actually has a heater inside a ceramic element, so it runs at approximately 700 degrees centigrade in there, 700 or 800 degrees centigrade. I put this slide in because this actually refers to not to any particular platform where you may have seen other NOx sensor improvements, but this is a implementation of a new sensor. This new sensor is designed more like the head that you see on the ammonia sensor that sits in the tailpipe next to the NOx sensor. We don't see NH3 sensor or ammonia sensor failures due to water. So we're now rolling this out onto four-wheel drive tractors. This should be in from, I think it's the Q3 of this year. It will involve, and that's because we have seen ongoing failures after the previous improvements to the heat up and detection modes. If there are ongoing issues on any other platform, it's likely that this will be proposed. It does involve complete recalibration, complete recertification of the engine and emissions, or ATS performance. And when we would replace a NOx sensor in the field, this would mean we would have to replace 2 and update the data set eventually. So this is a bit of a visual on what will be coming in the future to fix any ongoing issues. Okay, I think we're probably down to the last 2 here. The NH3 sensor itself, I just mentioned that. We actually have 2 issues that we've identified with this part. One, this is the first one. It's actually on the sensor part itself. The heat shrink around a splice was too short. It was letting water into the wiring and causing an error. We've improved the length of that heat shrink, and that has been rolled out, and the part number is being released across all of the vehicle platforms. Let's go to the second ammonia sensor, NH3 sensor failure mode here. This is actually a error codes, was it 19012? What we see here is that the vents in the sensor itself can become clogged, and when they become clogged, it applies a pressure to the ceramic element. This again runs on a heated ceramic element, so a fragile part, and the crack here is a different crack to what we were seeing on the NH3 sensor. It's due to the element heating up too quickly and not heating hot enough to clear these ports. So rolling out as at the moment, starting with the CCM, so the Puma, and going across all the tractors as a priority, is a new part number for the control unit for the ammonia sensor. This will heat the sensor up more slowly, and it'll also heat it to a higher temperature. Final part, sorry Rick, this is just the sending unit for the F5. We're rolling out a new component with improved sealing on it at the head to stop water ingress and to stop moisture becoming trapped and damaging the electrical circuit inside. I have breakpoints for TLB skid steer. I will update the slides with the one for the tractor. This is going to correct approximately 24% of failures. We're continuing to have these on recall, as currently 76% are classed as no trouble found. Okay, Rick.
All right. We've got one question that came in. I'm not sure if you got any insight on. It's a question pertaining to a PIP on the Magnums where they're replacing the valve covers, gaskets on them due to overheat situation. Should they be replacing the fuel crossover lines then when they're performing that PIP?
Yeah, if you have to remove the lines, I think it's is it just the input line there that you have to remove? But yes, if the lines have to be removed, we need to replace the.
Okay. We may have to look into that. I don't think the lines are included in the PIP, but I don't remember the exact details of that PIP. So
I think that's a good question.
Yeah, we'll have to look into that. I would say push that one back to your MFSO, and in the meantime, we can do a little more checking into that to see what everything is, or what the details of that PIP are. So, okay, that seems to clean up the questions that we have posted to this point. I guess that pretty well wraps this particular session up. Kyle, did you have anything you wanted to add?
Nope, that pretty much looks like we got everything covered.
Okay. Well, thank you, everyone, and thanks much to you, Ivan, for presenting this information. Thanks, everyone, for calling in.